Word problems are really where a lot of people have difficulty in chemistry. It's a lot different than the math that they've done before, and yet it's still has some theory present in it, and it's really there to make you think. Sometimes instructors will say the reason why you have to take chemistry, even though you might not be a chemistry or a biology major, is because we want you to think critically. That's very true. And one of the ways that we can get you to think critically is to test you with word problems. Just about anybody, given enough time, could solve simple mathematical and algebraic problems. It's the ability to put difficult concepts into workable function that really sets chemistry apart. So there's many ways to approach a scientific word problem, and I hate to tell you, but there are going to be a lot of them this semester. Again, it's a good assessment on whether or not you understand the material. And the problems that you get aren't going to match exactly with what you did on the homework, because I want to see if you can take the technique you've learned or a relationship you learned and test it in a new way. So there's a lot of different ways to approach a chemistry problem. I've come up with one. I'm going to tell you about another. There's a lot of different ways out there, but what you need to do is just find a way that works best for you. So the first thing I'm going to suggest is that you just read the problem. Read it completely through. Okay? Don't worry about where you're trying to go, what you're trying to get. Just look at it. Now, there's going to be times whenever you're like, oh, I know exactly how to do this. Get started. Just start working through it. Don't worry about the rest of this. Go ahead and work through. If you are stumped, though, the next thing that I suggest you do is write down the info in the problem in a clear way. So that means if you see that you have densities listed in there, you have percentages, write them in the ratios that you understand. Don't leave them in the problem. Another thing that you can do here, just to help you out, is use a highlighter. So highlight the important part. Okay. Sometimes at this juncture, it's also nice to highlight where you're going. Sometimes I tell students to do a roadmap, right? So if you have, I'll do it down here at the bottom, you know that you are trying to get to grams of a substance, and yet you're starting off with atoms of a substance. So there has to be a way to get from there to there. So figure out where you're going. It's very important, and it's also very important to figure out where you're starting. Sometimes that's not always clear. Another thing that can help you out is to write out the equations that are helpful. And I literally mean write them out. Don't look at them. Write them out, because writing them out will help get your brain going. One of the things that I definitely recommend for a student is to, once you've read the problem, don't sit there and stress on it. Don't sit there and itch your head. Don't worry about it. Just start writing something, okay? Because when you begin to panic, you stop thinking clearly. So write these things down, okay? The next thing is that units have to cancel out appropriately. So always look for proper unit cancellation. Once you have everything set up and it's ready to go, then do the calculations. Just put them into the calculator, get an answer out. Okay, do all the steps that you need to. The final thing is to check your answer and make sure it's reasonable. If I ask you how many atoms are in a ton of carbon and you tell me there are half an atom, that doesn't make sense. Okay, you need to make sure that your answers make sense. Look at orders of magnitude. Okay. I've also posted a 12-page PDF from, sadly, a deceased science instructor. The information in there is really great on how to tackle chemistry problems. One of the things he mentions is to understand the language and vocabulary. Oftentimes in class, I talk about chemistry being its own language, right? There is a big difference between ammonia and ammonium. or there's a difference between sulfate and sulfite. There's a difference between percent mass and percent volume. Okay. There's a difference between density and percent mass over volume. Okay, so understanding these differences and understanding the language is a very good first step into being able to solve these types of problems. So let's try a problem out. Here we have a fishing boat that it spills 3.0 barrels of diesel oil into the ocean. And what we want to do is we want to figure out how many square meters will the oil slick cover. It's pretty interesting because I believe this problem is going to take us through not only a dimensional analysis, but also an algebra problem. And that's something that you could expect. So let's take a look. We have some knowns here. We know that we have 3 barrels of diesel oil. We know that a barrel contains 42 gallons. We know that the oil film is going to be 2.5 times 10 to the 2 nanometers thick. One of the things we're going to talk about in class is some basic algebra functions where we have volume is equal to area times height. So if I'm looking for square meters, that's an area. So essentially, in order to kind of complete this problem, I'm going to need a volume. So let's continue to identify now where we're going. We've kind of highlighted some of the stuff that we know. Let's figure out where we are going. My final answer needs to be in area. I'm starting off in barrels. So in order to get into something useful, first thing I'm going to do is rearrange this equation. So I have volume divided by height is equal to area. And I know, and I'll put it in green, what the height is. So I need to find the volume somehow. So somehow or another, I need to get the volume. Another thing is that this needs to be in meters squared. So at some point in time, I'm going to need to convert from nanometers or wherever into meters. So I'm going to add another little arrow here to show that I need to convert into meters. So I have volume, but it's in terms of gallons. So I could go from barrels to gallons. But I need something that I can use in order to get from gallons into cubic meters, into cubic nanometers, into something useful. There's a conversion that you're going to need to memorize in class where 1 cubic centimeter is equal to 1 milliliter. So now, if I can get into milliliters, I can get into cubic centimeters, and then I can convert to nanometers, I can convert this to meters, I can convert this to meters cubed, I could do something. So the last thing I need is some way to go in between gallons and milliliters. One of the ratios you'll find in your packet is 1 gallon is equal to 3.785 liters. I have basically everything that I need now. So let's go ahead and try this out. I'm going to stop right here and then do some more calculations. Many times you're going to find that these problems have multiple steps to them. So I have 3.0 barrels. I need to get from barrels into gallons. So I'm going to start a big old dimensional analysis problem. So for every 1 barrel, I have 42 gallons. Now I need to get into the metric system because the empirical system is stupid. So I have 1 gallon to 3.785 liters. Now, how do I get from liters to milliliters? This is something you have to know. You have to have memorized. So you could use either of the systems that I showed you in a previous video. So I like to work in positive exponents. So I'm going to say 1 liter is 10 to the 3 milliliters. And then I have a conversion to go from 1 milliliter to 1 cubic centimeter. Now what I'm going to do is I'm going to go ahead and put myself into meters because it's a little easier, and then later I'll convert my nanometers to meters. So for every 100 centimeters, I have a meter. But notice this goes back to an earlier problem where I can't just cancel these units out like this. I have to cube this. Now, what this is going to do is it's going to put me into cubic meters. At this point in time, it's a good idea to go ahead and double check to make sure my units are going to cancel out. So I cancel out barrels, cancel out gallons, cancel out liters, cancel out milliliters, centimeters with cubic centimeters, cubic centimeters with cubic centimeters, and I'm left with cubic meters once I cube everything. So at this point in time, I multiply everything across the top, divide by everything on the bottom, and I get 0.47691 meters cubed. I need to check my sig figs before I move on. So 7 is my last sig fig. Now this isn't my final answer because I need to be in meters squared. So now I'm going to bring this equation back up. In order to cancel out meters cubed with a meter to get meters squared, I'm going to need to convert this nanometers to meters. So if I go back, I'm going to have this memorized, that the relationship between nanometers and meters is 10 to the 9th or 10 to the negative 9th, depending on how you work through it. So I have 10 to the 9 nanometers in 1 meter. This gives me 2.5 times 10 to the negative 7 meters. Now I can take this and plug it into this equation. So I have meters cubed divided by 2.5 times 10 to the negative 7 meters. Notice that this is going to give me meters squared. So my units match up. And when I plug this into my calculator, I end up getting 1.9 times 10 to the 6 meters squared. These are typical types of problems that you're going to see in Chem 1A. They differ a lot in the amount of work that you had to do in earlier chemistry. So it's important to find a setup on identifying word problems that works for you. You're going to have to be able to think on your feet. You're going to have to be able to apply the things that you've learned in order to succeed in this class.